Week 10 notes, finding the greatest common factor, or GCF. You might be familiar with the GCF from prior years in math, but we're going to go over it again. But to find the GCF of two numbers, you have to ask yourself the following question and write this down. What's the biggest number that both of the numbers can be divided into? Again, what's the biggest number that both of the numbers can be divided into? Okay, so we can make more sense of that. Let's do some examples. Number one, I'll give you two numbers, 24 and 32. What's the biggest number that both of these numbers can be divided into or divided by? You may know the answer right away if you're good at your multiplication tables, but if you're not so good at your multiplication tables, I can show you another way to find it. But one way to maybe think about it is ask, what can I divide 24 by? Well, it's even, so I can definitely divide it by 2. I can divide any number by 1. So I can divide it by 1, I can divide it by 2, I can divide it by 3, I can divide it by 4, I can divide it by 6, 8, 12, and of course 24. If I'm going up through all those numbers, I need to ask myself, what's the biggest one of those that I can also divide 32 by? And that is the greatest common factor. If you don't know your multiplication tables very well, this is going to be challenging for you. But I'm, again, going to show you a way to do it that takes some of the complexity out of it. So let's try something. We're going to look at these numbers and notice that both of them are even. That means that you can definitely divide both of them by 2. So write these brackets like this, and then put a 2 in there, which indicates you're dividing them by 2. 24 divided by 2 is 12. 32 divided by 2 is 16. And we're going to keep doing this and whittling these numbers down until they no longer have a common factor or a number that we can divide both into. So 12 can be divided by 2 and 16 can be divided by 2 because they're still both even. 12 divided by 2 is 6. 16 divided by 2 is 8. We can still divide 6 and 8 by 2. Let's keep doing that until we cannot anymore. 6 divided by 2 is 3. 8 divided by 2 is 4. We're left with 3 and 4 now. And these numbers no longer have a common factor except for 1, because you can divide anything by 1. But what we have in the center here is the thing that will allow us to figure out our greatest common factor. And what we have to do is multiply the numbers in the center together. That will give us our GCF. So 2 times 2 times 2 is 8, which is the GCF, the greatest common factor. And if I can show you here, 24 divided by 2 times 2 times 2, which is the same thing as 8. 24 divided by 8 is 3. And 32 divided by 8 is 4. So you can see the relationship here. And in your classwork, I require you to circle your GCF. Right there, you would circle it, but I kind of did here. And then you're writing the numbers that these two numbers would become after you divide the GCF out. Let's try another one. 36 and 30. What's the biggest number that both of the numbers can be divided into? And I'll allow you to pause it for a second to try and figure it out. assuming you've tried it. 36 and 30. Well, some of you may know it right away if you're good at your multiplication tables, but if you don't, then you can definitely notice that they're both even. So let's divide both of them by 2. 36 divided by 2 is 18. 30 divided by 2 is 15. 18 and 15. Do these have a common factor? Can we divide both 18 and 15 by something? The answer is yes. And that number is 3. And you should know that. 18 divided by 3 is 6. 15 divided by 3 is 5. And now we have 6 and 5. These numbers no longer have a common factor except for 1. So we can't divide them anymore. So we circle our numbers in the middle here, the middle channel, and then multiply them together to get our GCF. 2 times 3 is 6. And again, if you were really good at your multiplication tables, you could have looked at these and figured that out and just done this in your head, which is the goal, but you may need to do these steps first. Try this one, 15 and 25. Assuming you've tried it, 15 and 25 can both be divided by 5 since they both end in 5. So let's divide out 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And 3 and 5, well, they don't have a common factor anymore. So that's as far as we can go. Therefore, the middle number right here is our GCF. GCF equals 5. This is a pretty good method. I like this. It works, but eventually, like I was saying, I'd like you to be able to do it in your head. One more, 23 and 17. Think about this one for a second. Try and do it on your own. Assuming you've tried it. You may be like, I don't understand exactly how to do this because 23 is a prime number and 17 is a prime number. That means it can only be divided by 1 and itself. So how do you do this? Well, since all numbers, no matter what they are, can be divided by 1, then 1 is in fact our GCF. And we're done.